Our final presentation is on development of PID controlled inertial stabilized platform. Again, a joint project by Mr. DD Perera, DT Vidanagamage, DC Perera and others. I think the presenter is Mr. DD Perera. May I invite him, please?
Good afternoon, everybody. I'm going to present the development of PID control initial stabilized platform. What is an initial stabilized platform? It is control the line of sight of any such surveillance systems, gun radar, such as satellite antennas, and like that. Mainly ISPs use gyros measure the angular velocity related to the initial space and manipulate the platform achieve a required angular speed and maintain the stabilization of the line of sight using DC servo motors. Here we are going to use improved PID control mechanisms too, and under this project is going to develop a stabilized higher caliber weapon control system. These are my project steps. First, we data acquisitions by gyros and resolvers and tacos, and we use and the second step was the data processing, conversion binary gyro data to decimal data, and process data communication with motor drivers, and filtering gyro, taco, and resolver signals. And then thereafter, we develop a basic control algorithm and stabilize the gun mount using linear control algorithm. And then our target is to develop an intelligent control algorithm such as fuzzy logic and neural network because of the non-linearity behavior of and uncertainty of the mechanical system. Then you can see there any moving object. A ship mainly we consider the ships. It has 6 degree of motions, freedom, and it can be divided into 2 types: linear and rotational motion, which are yaw, pitch, and roll, and also linear heave, save, and surge. But we consider in this project only the rotational motion. According to the second pictures, you can see the guns becomes unstable due to the sea wave and wind. This is our project's system block diagrams. We use Canon 2 gyros to measure the angular velocity of the system, and base gyro and Canon gyro. And resolvers we use to measure the angular position, and DC servo motors used to control the our gun turret, and tachometers is used to measure the angular speed of the motor. And there are also there is a ballistic computer to give the tracking angle and the position of our targets of the system. This is the system peripheral arrangement. We use base gyro to measure the angular speed of the motion of the board, and DC servo motors used to use the control of the gun, and tacos and line of sight gyros are used to feedback the angular velocities, and resolver used to get the feedback of the angular position. And we use the gear wheel to gain a higher torque. This graph shows the raw angular velocity of the yaw and yaw, roll, and pitch angular velocities. It contains higher frequency noises. According to the fast Fourier analysis, then you can see there exist high frequency noises, and there exists a base peak which is the angular motion of the board. And we use the Kalman filter to filter this noises, and the second graphs you can see that we get a smooth angular velocity without the noises. Then this is the filtered signal data of base gyro. Then this is the system dynamics. We consider the Newton first and second law. According to its net torque is equal to moment of inertia into angular acceleration. Then any object, moving object, prevent a rotation. Its applied torque should be 0. Then we measure the angular velocity, and then using the base gyro end, we control the gun mount using DC servo motors. Then it gives the opposite angular velocity to the gun mount. This is the system dynamics and relative motion of the system. If the system is tracking a moving object, then you can see the relative motion of the gun should be not equal to 0, and its total angular velocity should be the rotational motion of the board and the rotational motion of the target angular velocity. And if the system is stationary, then angular velocity should be to the board motion and its opposite direction. And but the normal perfect system doesn't have frictions and wind torque and out of balance, but existing real-time normal mechanical system has friction torques and other disturbance wind torques and out of balance. Then it's make highly nonlinear behavior of the system. This is we use the closed loop PID controller, and we measure the command and get the error of the feedback using it may be angular velocity or angle. Then we drive the motor, we calculate the array and then get the proportional constant and derivative integral part and derivative part calculate, and sum of that values then drive the DC motor drivers. Then our system has two parts. The first is stabilize the system and the position in a particular target. Then we have to use dual feedback closed loop controller algorithm. Also then there we use the positioning PID controller in outer loop and the stabilization inner loop is used as the stabilization controlling. This is the output of our projects, and you can see there red line is show the board movement, and the blue lines present the takeoff of the angular velocity of the motor, and the black lines show the angular velocity of the line of sight gyros, line of sight, and you can see it becomes related to the board motion, it becomes close to the 0. This is another examples that we acquire data from different sea state. Then this is the tracking angle was the ISP control output. Then black line show the tracking angle of the tracking targets, and the red line show the angle position of the our system. It's very close to the tracking angle. This is the fast Fourier analysis of the our system. Then you can see there in red and green lines are the boat motion and the our motor angular velocity spectrum, and green line show the line of sight angular velocity frequency. It's become its base peak has cancelled out. Then our system becomes very stabilized against the angular motion of the sea wave and other disturbance. Future works of development of partial logic gain scheduling method for PID controller, because of the mechanical system is very non-linear. Therefore, we have to use a non-linear PID controller, and also we have a target also development of fuzzy logic PID control algorithm to train for the ISFP different sea conditions, and development of real-time prediction algorithm for base gyro signal using neural network.
Thank you.
Thank you.